Alright, the next thing to watch out for is with this series is called the sigma notation. Sigma notation is that big symbol that we saw last week that kind of looks like, well, a couple weeks ago that looks like this. This is sigma. Down here it should say n equals 1, and up here there's going to be a number like, and we'll just call it k for now. And then it will say a to the 1 times r to the n minus 1. If we remember, this is actually our formula for the geometric sequence. Okay, so this is a formula for the geometric sequence. Now, we actually don't work anything on this. This is just where we get our information. We're still going to use the same formula I showed you a second ago, which is a1. Sorry, that's a bad a, so I never write that. a1 1 minus r to the n over 1 minus r. Still the same formula, it just looks a little bit different how they set it up. Now what you need to know is this has to say 1 down here. I'll show you what I mean with an example in a second when it doesn't. Okay, but it's still going to work the same way, you just have to be able to get the information. So an example of one of these may look like something where it says sigma, which means find the sum from the first term all the way to the 10th term. So it says find the sum of 10 terms, -2 times 2 to the n minus 1. What you really need to be able to do is interpret this, okay? Meaning understand that that right there, that is a1, and this is your r. This up here is your n. Okay, this is your final number of terms, so don't let this throw you off. They don't always use n down here. You can use I or k or anything like that. This is telling you where to start. This is where to stop. So we would do the same thing. We're going to use the formula. We would just simply plug it in. So a1 is -2. I always like to put my negatives in parentheses. 1 minus r, which is 2. And we said we're going all the way to the 10th term over 1 minus 2. Now, like I said, cleaning this up is the real trick. Okay, I'm going to let you try it, see what you get. Like I said, I will make a video about how to do these into the calculator. But if you do this correctly, you should get -2046. Okay. Now I'm going to go to a new page real quick because I told you really need to understand that this n has to be 1 and this n has to be 1. So I want to show you what you would do if you didn't, if it wasn't 1. So again, still with the sigma notation. Okay, I'm not going to work an example with this, just try to explain this for you. It better say 1. Okay, so that last example went from 1 to 10. Well, if it doesn't say 1, you have to make it say 1. So, for instance, if it doesn't say 1, this time it says 0. So how do I go from 0 to 1? Simply add 1. But we have to keep it balanced. So what you do to the top, what you do to the bottom, you do to the top. It's like balancing equations. So now, what you really have, you're going from 1 to 11. So you have to make sure that this says 1. So another example would be if it said 2 down here and it said 13 up here. Well, that's not 1. We have to make it say 1 by subtracting 1. But what you do to the bottom, you do to the top. So that is equivalent from going 1 to 12. Okay, and it doesn't change any of the information out here like the A1, the R, anything like that, but you do need to make sure that it starts at 1. Okay.